the last thing that we're going to do is talk about how to tell if a series diverges. But before we can talk about this nth term test for divergence, we first need to figure out what we say about a series that converges. So now, if the sum from n equal 1 to infinity of a sub n converges, if this series converges, then the limit as n goes to infinity of a sub n is going to equal 0. So whatever this a sub n here is, if we take its limit as n goes to infinity, we get 0 if the series converges. We are going to use the contrapositive of that statement to prove divergence. So what we say is, well, if that's the case, then if when you take the limit as n goes to infinity of a sub n, you don't get 0, then your series diverges. So again, what we're going to say is if the limit as n goes to infinity of a sub n doesn't equal 0, this series is going to diverge by the nth term test. Please note that if you try the nth term test, if you take the limit as n goes to infinity of a sub n and you end up with 0, that tells you absolutely nothing. Your test is actually inconclusive. You can only show that a series diverges by taking the limit as n goes to infinity of a sub n, and that has to equal a number that is not 0. If you get 0, you have to pick a different test to determine if your series converges or diverges. Okay, let's recap what we've done so far in this section, and after we recap, we'll look at the last 4 problems. So for right now, all we know is that we can figure out if a telescoping series converges or diverges by finding the sequence of partial sums. Now, once we found the sequence of partial sums, if the limit existed, then our series converges and S was our sum. If the limit did not exist, then the series diverges. If we're geometric, so we look like the sum from n equals 0 to infinity of a times r to the n, so remember this is a number raised to a power, then we say the following. If the absolute value of that number is greater than or equal to 1, we diverge. If the absolute value of that number is less than 1, we converge, and you can find the sum using this formula, a divided by 1 minus r, where a is always your first term. And finally, the nth term test. Now, the nth term test can only be used to tell us if our series diverges. What it says is that if you have a series, so the sum from n equal 1 to infinity of a sub n, if you have a series, you look at a sub n. If you take the limit as n goes to infinity of a sub n, and you end up with something that is not 0, then your series diverges. If you end up getting 0, then your test is inconclusive. You got to pick a different test because you still have no idea if your series converges or diverges. So let's look at the last 4 problems in this section where we're trying to determine if a series converges or diverges, and if it converges, we're going to find its sum. Number 5 is the sum from n equals 0 to infinity of the square root of 2 raised to the nth power. Is this telescoping? No, I don't see a minus sign. Is this geometric? Yes, because it's a number raised to a power. So we know that r here is going to equal the square root of 2. Now the absolute value of r is still equal to the square root of 2, and we know that that number is approximately 1.4. Since that's greater than or equal to 1, we know that that means that this series diverges. Again, why does it diverge? Because it's geometric and the absolute value of r was greater than or equal to 1. What about number 6? The sum from n equal 1 to infinity of 3 times 2/5 to the n. Well, this is still a number raised to a power, which means I'm geometric. r here is equal to 2 over 5, which means that the absolute value of r is still 2/5. Well, 2/5 is a number that is less than 1, therefore that means that this series converges. Why does the series converge? Because if the absolute value of r is less than 1, the series converges. Now the direction said, if your series converges, find your sum. Now let's find the sum of this convergent series. So recall, our sum formula is a divided by 1 minus r for a geometric series. All we have to do is figure out what my first term is because I already know what r is. How do I find my first term? Plug in the counter in place of your n in your formula. So when n is equal to 1, I get 3 times 2/5 to the first, which is 6 over 5. Therefore, my sum, S, is going to equal A, which is 6/5, divided by 1 minus R, which is 2/5. Grabbing a calculator, 6 divided by 5 divided by 1 minus 2 divided by 5. You hit enter and you end up with 2. That means that this sum is equal to 2. What about example 7? The sum from n equal 1 to infinity of 4n plus 1 divided by 3n minus 1. Well, I don't see a minus sign for telescoping, and this is definitely not geometric because it's not a number raised to a power. Well, let's go ahead and try the nth term test. So the nth term test says to take the limit as n goes to infinity of a sub n, of this guy. What is the limit as n goes to infinity of 4n plus 1 over 3n minus 1? Well, currently that's just infinity over infinity. Since this is n to a power divided by n to a power, we're just going to put those over each other and then reduce. So we're looking at the limit as n goes to infinity of 4/3. Well, what's the limit as n goes to infinity of 4/3? Well, that's equal to 4/3. Well, 4/3 doesn't equal 0. Therefore, we know that this series is going to diverge because the limit as n goes to infinity did not equal 0. We say that, therefore, our series diverges by the nth term test. Finally, number 8, the sum from n equal 1 to infinity of the natural log of n over n plus 1. I don't see a minus sign, so I don't think telescoping. It's not geometric, so let's try that nth term test again. Well, what happens if I take the limit as n goes to infinity of the natural log of n over n plus 1? Well, the limit of the natural log is the same as the natural log of the limit. So we're going to rewrite this as the natural log of the limit to make it easier for us to evaluate this. What is the limit as n goes to infinity of n over n plus 1? Well, this is just like the last one. When I put n over n, that's just going to reduce, and what is it going to reduce to? It's going to reduce to 1. So we're looking at the limit as n goes to infinity of 1. Well, what's the limit as n goes to infinity of 1? Well, that's just 1. What's the natural log of 1? 0. Well, this is equal to 0. What does that mean? My test fails. Why does the test fail? Because for the nth term test, if you end up with 0, it tells you nothing, it's inconclusive. We got to choose a different test. So the only other option is to make this into telescoping. Why? Because there's no way I can make that into something that's geometric. Well, how can I make this into telescoping? Well, this is the natural log of a quotient, so we can use that quotient rule. We know that this is actually equal to the sum from n equal 1 to infinity of the natural log of the numerator n minus the natural log of the denominator n plus 1. Because the natural log of a divided by b is just the natural log of a minus the natural log of b. Well, now we're definitely telescoping because we have that minus sign. So let's find the sequence of the partial sum. S sub n is going to equal, when I plug in a 1, I'm going to get the natural log of 1 minus the natural log of 2. Plug in a 2, and we get the natural log of 2 minus the natural log of 3. Plug in a 3. We get the natural log of 3 minus the natural log of 4. Then I'm going to move us to the bottom, plus dot dot dot. Plug in an n equals n minus 1. And we get the natural log of n minus 1 minus the natural log of, well, n minus 1 plus 1 is just going to be the natural log of n. And then finally, when n is equal to n, we have the natural log of n minus the natural log of n plus 1. So what if anything cancels? Well, here I notice that natural log of 2 cancels, natural log of 3 cancels. I know this term would cancel if I were to write the next term. Natural log of n cancels, and I know this term would cancel if I would have written the previous term. That means that my partial sum, s of n, is just the natural log of 1 minus the natural log of n plus 1. Well, the natural log of 1 I know is just 0, so I can just say that my partial sum is negative natural log of n plus 1. Now I need to find the limit as n goes to infinity of the partial sum. So the limit as n goes to infinity of negative natural log of n plus 1 is going to be, well, the negative comes along, and when you think of infinity plus 1, we know that's infinity, and then the natural log of infinity is just going to be infinity. Therefore, we get negative infinity. Well, what did that mean? That means that the limit didn't exist, and if the limit didn't exist, we knew that the sequence diverges. And if the sequence diverges, therefore we know that this series will also diverge. That's it for series and convergence.